All right. So, okay. So last 30 minutes. So I want to shift to the discussion to more conclusion-like discussions. But of course, it's impossible to conclude. uh, Here, so that not I won't conclude only this discussion, but I think we should clarify or propose a cognitive robotics problem. That is, that means that we need to set a clear goal that can be a basis of the basis to overcome the uncertainty problem when we achieve the goal. So that means that, so please recall the DARPA robotics challenge. That is, I think that was a great success, and they set a clear problem, and if they overcome the problems, something new, intelligent system appears. That is a good setting, but we need like that. That was a competition, so it takes time and takes money for joining that. But so I think that like that, we should clarify some problems. So like the robot can do something in something environment. Such kind of problems, if we clarify these kind of problems, that can be a very good target for us, for robot researchers, what we should do for overcoming this problem. So I want to discuss this. I want to start discussion about this problem in this roundtable discussion, and my idea about this discussion is we start discussion this problem in this roundtable, and I will summarize this discussion for review paper in Advanced Robotics special issue that doing the Professor Taniguchi and Professor Nagai. But this is all still not completed. We should keep discussing this one in conference. The one of the best conference for us is ICDL, International Conference on Developmental Learning. That will be, next one will be held in 2021, and Alessandra will be a program chair of that. So that should be the good timing, good opportunity to make another workshop there. And also we can use ICRA, ILOS, and also Shona meeting for keep discussion. And we should summarize this one and propose in, for example, that IGB transaction cognitive development systems as a cognitive robotics problem. That is my idea. So I want to start clarifying this kind of problems in this roundtable. So can you understand what I mean? Okay. So, but I think that, how do you think that for robotics researchers, very clear target is important. So robot, some kind of, so like walking robot can do in something in something environment. If we can set such kind of problem, very clear for researcher. On the other hand, so if we set the problem, we can ignore uncertainty. That is a trade-off problem, always, for setting this kind of problem. If do you have any good idea for overcoming this trade-off, please make comments.
I think, well, I can start maybe just with a comment.
Yes,
so about the physical interaction. So of course, these things are discussed also not just in cognitive robotics, but also in general robotics.
That's true.
And for example, for manipulation, I mean, people are now talking a lot about benchmarks, right? So having some kinds of benchmark that could prove that, you know, that you achieved certain milestones in the development. And as you said, the problem is that if you fix a certain scenario that has to be addressed, then any solution can just overfit to that specific scenario. And I don't think those are the solutions that we need, as we discussed in today and in general in cognitive robotics. So more interesting is to have something that can work in all the different scenarios, right? So of course, one approach for that is to have something that is then, let's say, an algorithm or a solution to a problem that is then shared with the community, and everyone should have the possibility to test it in their own scenario, so that you can, ideally, I make the example for a grasping algorithm, something that I develop, and then 1,000 people in the robotics community, each one of them can test it in a different scenario. Then you can say, okay, this generalizes very well. And we discussed today how generalization, it's something important also to have, let's say, the actual uncertainty that we have in real world. So I think maybe, let's say, in general, having the participation of the community in this sense can be something interesting, and that will require not just defining the goals or the benchmarks, but also making, let's say, code or let's say your solution fully available to others, so that it can be tested in different scenarios. Because I think this generalization to any kind of environment is something very, very important.
Okay, thank you very much. So very important comments. Any other comments?
I have another comment.
Yes,
and even reading, let's say, even coming from or reading comments from cognitive science or from biology, it emerges that sometimes there is not yet a clear idea of what the whole idea of cognition entails, which are the basic elements that are necessary, and how these elements should be interconnected or put together into a whole architecture to allow for cognition to emerge, to appear. So I think that one problem, but I think it's a problem zero, I don't know if it can be listed as one of the step problems, is really trying to understand which are these components that we need. A lot of them have emerged, have appeared today, generalization for sure, but as elements that need to be present, so as long or lifelong learning, or a memory, as Shingo was pointing out, as prediction, prospection. So already having so establishing, if not a consensus, at least an open discussion on how these different elements should come together, or which of them are really needed, which of them emerge as a consequence of basic abilities. That's already, to me, quite an open and interesting question. And in addition to that, I really believe that this question goes beyond, so it is crucial for cognitive robotics, but it goes beyond the domain of engineering but even of cognitive science per se. It's really a question that we should ask at large. So as the distinction between self and other that was mentioned before, we need inputs also from philosopher. We need inputs from a wider range of expertise that go beyond engineering per se and cognitive science and even neuroscience. So this occasion of discussion could be a nice way to open up the doors and start asking these questions and asking for participation beyond the entourage, let's say, that is discussing this topic now.
Okay, thank you. Any other comments? Yeah, based on the, sorry, go ahead. Yes, Dimitri.
Yeah, one thing I was pointing out is what is called also theory of mind. So being able to be aware of others' mental states. I think this is a very important task for a cognitive robot that is kind of out of like technical robotics. but it's crucial to have robots to collaborate with us. And as, let's say, to be able to understand our mental states, they must be in some way cognitive, because they have to understand a cognitive being. And I think that even if it is difficult to really define what it is to predict other mental states, we can try to define tasks where understanding other beliefs and intentions, at least, could be like point zero, or like Alessandra say, so could be more used like a DARPA competition for human-robot collaboration, where actually there is stress on understanding the human belief, to know what it thinks is where, or this kind of thing. And the problem of generalization is very important, because obviously if the task is always the same, obviously there is no uncertainty on what the human knows or not. But I think playing about this kind of problem, so an interaction where the state of the human is crucial, I think can be a starting point for defining a challenge. My doubt there is how much we should allow for language. It is crucial for the interaction, and I don't know what comes before, the theory of mind or the language. But I think having a theory of mind or having an estimation of other beliefs and intentions is an interesting task, an interesting step for robotics that we are in cognitive robotics, and standard robotics is kind of forgetting at the moment.
Okay, thank you very much. Yeah, generalize, how to describe the generalization problem is the key, should be the key of this kind of problem definition. So one of my idea while hearing your comments is we define not only one problem, but a kind of problem series of the problems. For example, that if we define the problem of open the door of the room, before opening the door, we should define the task. We can grasp the variety of kind of objects, for example. If we can do that, next we can set open the door. In that case, we need to how to say that, grasp the handle of the door, many kind of handle of the door without caring. And if we open the door, the robot success and open the door. Next, we need why the robot need open the door. There should be, for us, for human beings, always there are any reason why we open the door. Not in our life, open the door is not always a final goal. There is a reason of opening the door in context base, because I want to go out, or somebody will come, or we bring out something from the inside to the outside. Because of that context, the how to open the door should be changed. So if we define clearly as a series of the problem, even each problem is very, very concrete target without uncertainty, but as a result of a series, uncertainty might exist. We might set the problem series that exist uncertainty between the connection of the problems. Might be possible. I thought from your comments. Can you understand what I mean? How do you think? Or of course, that I want to ask that point, the Professor Oseki. What is one step before of language communication or language learning? Do you have any idea for that? Of course, that is the same question, Professor Taniguchi and Professor Nagai.
Wait. So what's the question? So what's the basis for language learning?
Yes, a kind of basis of language learning or language communications.
Yeah, that's another hard question, but Dimitri pointed out, yeah, theory of mind is one candidate as a basis for language learning and acquisition. And also, like, some people argue that like joint attention in the noisy or actual environment is another source of language learning, like a bootstrapping language acquisition, like by using like a multimodal information. So yeah, so let me summarize what I said before. So the one reason why language like is thought to be special is like some people believe that the human linguistic knowledge cannot be learned just based on experience, like without assuming some innate knowledge, like genetically, right? Yeah. I think one future direction is to reduce the amount of data which we give to maybe robots or models. Okay, and we only use the data which is equivalent to the amount of data which is available to actual human babies or human kids. And we just give a small data set to some robots or babies. And maybe the learning succeeds or may not succeed, but the important point is to borrow insights from cognitive science, as Alessandra said. We can inject some like cognitive biases or inductive biases to the models and to assist the language learning, for example. And that could be like one like future direction. Yeah. And another condition is those like models or robots should be able to make generalizations beyond the training, the available data. So that's really a current issue in NLP, like how we can create the machines which can generalize beyond training data to unseen data. And we have to have some inductive biases, maybe like compositionality or like some latent structures to combine like items into like some higher order representations to make generalizations to adapt to unseen environments maybe. So that's really a key point to get some generalization capability, maybe compositionality or latent structures or some like traditional symbolic like insights, I think.
Yeah, that kind of generalization for language used based on experience. That is one of the very mysterious capability of human beings. But this mysterious capability, how do you think that if you modeled in robot, Professor Taniguchi and Professor Nagai, what do you think about that? How you can discover this mystery for robot technology? Taniguchi, you are meeting? Okay.
Yeah, sorry. Yeah, I am very much agree with Ozaki-san. So the reducing the number of data for the language acquisition is a challenge. And actually that is very nice topic for robotics. And for example, so the NLP people tend to ignore the other modality information. For actually this world, our world is structured itself. And our behavior is also structured. And actually, in the Dimitri's the introduction presentation, he showed his work upstairs. That is related to the action grammar. Is it true? Yeah. yeah. So the action grammar. So when we perform some sort of the manipulation or behavior, the behavior itself has some sort of the syntax. So such kind of information or experience can bootstrap the syntax learning and language learning, I think. So but to introduce such kind of multimodal and action information to language learning, so we need to study robotics and the language together. So actually, this is a very nice topic for cognitive robotics, I think. In addition to that, so the most very important point is that the language learning should be situated. So the all text data, for deep learning is almost away from the actual situation of our daily life. And it's very much related to a challenge, the challenge for robotics. I keep it in my mind. And that's very related to the lifelong learning Alessandra mentioned. And actually, I think the very important challenge is that the a partner robot should survive in the daily environment as a partner robot. I mean that this is the kind of irony. I think that, but I have the Alexa, Amazon Alexa in my home, and automatic vacuum cleaner robot that made by Panasonic. It's called Ruro, not Roomba. So in a room, but both of them are turned off by my children. And actually, they get bored, the robot. And because, so they never adapt to our communication or our daily life. So the robot need to learn in an endless manner, continuously. So that will prevent the children from get bored. So in the robot, the cognitive robot should learn many things in the situated scenario and environment. So just living together with people in the home environment is a huge challenge, I think.
Okay, thank you very much. What do you think, Professor Nagai, about your model-based language analysis point of view?
Well, I totally agree with Professor Taniguchi, and I think I'm not sure this is a good answer for your question, but I think kind of field work is very important. I mean, I want to build a kind of cognitive model, or as I said, world model, which can run or the self-organize the multimodal information and make the robot run from scratch. I mean, not exactly scratch, but there are some functionality required as newborn baby. But anyway, I want to make a kind of learning model and let the robot run in the real world. And maybe Japanese people remember that there was a challenge called Torobo, which is tried to make robots enter the University of Tokyo. And that was actually, I cannot say that was fail, but actually the robot cannot enter the University of Tokyo. But I think before making the robot enter the university, I think the robot needs to go kindergarten. So my milestone is to make the robot enter the kindergarten. So it's really important to run a lot of things, not only a physical world, but also make a friend and how to interact with other people and so on. So that kind of, field work is a good challenge or the test for the cognitive robot.
All right. Okay, thank you very much. So now time is getting approaching. So, but there's a few questions from YouTube. Can you, Alvaro, make a talk?
Yes. So, okay. So first question here is by Munesh Chauhan, which the question says, are are there any issues with regard to computational complexity in robotics? And does this field require inputs from parallel computing, GPU computing? So I guess this question is, of course, is talking about the computational complexity that we have to, that is a challenge in this field when we are trying to implement the kind of system we are talking about. I think in this, so to open a little bit the view in this question, I will say that usually when we humans want to move forward in any field of science, there are, let's say, two different things we have to take into account. One is, do we know how something works, or do we know how to do something? And if we know, then can we actually do it? Now, in this case, this computational complexity will be if we can do something. So in this case, we were talking about things like self-awareness, consciousness. I don't think nowadays we even know how consciousness is, but even if we know and we knew how to implement it, there will be a technology advanced enough in order to implement this. I think this question is in this regard.
Thank you very much, Alvaro. So someone can respond to these questions. How about Nagai-sensei about the consciousness implementation?
It's really hard. I said that that is the hardest or the last problem we have to solve. So right now, I have no idea, but there are a lot of research on consciousness in the neuroscience and cognitive science. So we have to refer that their works. And currently, the dominant approach for that is kind of the use of the information theory, like in IIT, integrated information theory or something like that. So the possible challenge is to, as I said, make the robot learn something and then analyze the kind of information using the information theory or something. So, but I'm not right now sure what it is actually the consciousness is, and also how we can implement, or that is just a kind of emergence, or, you know, I don't know at all right now. So
okay. I have one question related to that. So if for human beings case, consciousness appears all behavior. For just grasping, we can understand he's angry, why, or he's very sad. How do you think such kind of the end of our behavior, why we appear the consciousness, or such kind of one is important for robots for interacting with the environment or not? Do you have any comments in that point? How about Lorenzo? How do you think that for grasping, for example, for grasping consciousness is important or must be for natural motions, or we lost connections?
I think it's a hard question to answer. So
maybe he was scared by the question.
Oh, Julio.
Right.
Do you have any comments for that?
Well, you know, I think, you know, consciousness is a very interesting topic, worth discussing, you know, very often and with as many people as possible. But, you know, on the other hand, I think, you know, you should see consciousness as the final goal somehow. And we cannot skip all the intermediate ones. Intermediate goals, which I think are in some sense more important. You know, not that consciousness is not important. On the other hand, is the top somehow. But in order to get there, we have to understand a lot of things before that. So it is nice to talk about that as a goal, you know, as a final goal, but then, you know, to take it as a stimulus to try to solve problems which are, let's say, techable now, and that will pave the way toward consciousness. So in that sense, I think we should talk about consciousness in that sense, not as something that of course can be solved now, but as a sort of a long-term goal, that we all aim at, but then try to see what are the obstacles between where we are now and consciousness, and try to go on incrementally without hoping to find the answer with just a single jump. So
Okay.
that's, yeah.
Yeah, thank you very much. Very good comments. Okay, so unfortunately, the closing time is approaching. So we should keep discussing for clarifying the cognitive robotics problem in coming conferences and also many meetings.